Welcome, everyone. We'll get started in a moment. We'll be starting at 4:02, so just give us another moment. I still see new participants joining. Okay, I think we'll go ahead and get started. Welcome back, everyone. We've been away for the summer. Welcome to the fall. Welcome to the October 2023 edition of Green Infrastructure, Climate, and Cities. This is a monthly seminar series put together by the partners shown on the screen, funded by NOAA through the CAP RESA program to really focus on the unique challenges of climate change and cities and solutions. My name is Franco Montalto. I'm a professor here at Drexel in the College of Engineering. I'm one of the lead principal investigators for the Consortium for Climate Risks in the Urban Northeast, which is a NOAA-funded team of researchers that's looking at this topic. This seminar series goes back several years now. All of our seminars have been recorded and archived on the CC Run website. We're actually going through an update of that website right now, but you can still see prior versions of this seminar there. And within a few weeks, we will have the new updated website with everything transferred over there. So feel free to go to the CC Run website to watch this or any of our other previous webinars. Also, in case those of you who don't know this, we offer continuing education credits to attendees, and there should have been instructions when you registered for this seminar. So today's the topic for this month's seminar is measurement and mitigation of urban heat islands, and we have two presentations that will go back to back. The first is Jen Brady, Manager of Research and Senior Data Analyst at Climate Central in Princeton, New Jersey. Brady's work focuses on measuring and communicating the effects of climate change at the local level, including changes in temperature, precipitation, as well as the impacts of these changes. And she's led work on urban heat islands, power outages related to extreme weather and climate disasters. So after Jen's presentation, we'll move into Nikki Pearl's presentation. Nikki is right here at Drexel University. She is the lab manager for the Sustainable Water Resource Engineering Lab and an active researcher within CC Run. Nikki's work focuses on integrating research, civic science, community engagement, and education to equitably address the impacts of the climate crisis. And Nikki will present some of her work this summer, where she spearheaded our lab's heat mitigation project expansion, co-coordinating the implementation of over 200 shade structures in a number of Philadelphia neighborhoods that are disproportionately affected by extreme heat. So during the seminar, please use the Q&A box, not the chat, to submit questions. You can also upvote questions that have been asked by others, and raise your hand to ask a question orally, although that will be unlikely with the number of participants we have. We're over 50 right now that will be able to take oral questions. So please submit your questions in the Q&A box. Just use the chat box for technical questions associated with if you're having trouble understanding how to use any of the technology. So with that, I will hand it over. I will stop sharing my screen and hand it over to Jen.
I will unmute. Hi. Thank you for inviting me to the seminar, to the first one of the year. Very happy to be here and talk to you about some work we've been doing here at Climate Central on urban heat islands. First of all, I'm going to introduce Climate Central. We are in Princeton, New Jersey, though, as many people now, we're hybrid and we're a little bit everywhere. This is our motto, science made clear, climate made local. And our goal is to communicate science of climate change in a way that can be really understood by the everyman. We use trusted messengers. This is what we call our journalists and TV meteorologists, and more teachers and others that use our materials to communicate the basics of climate change and what's going on. At this moment, we have over 3,000 meteorologists and journalists that work with us nationwide and at the local level. We try to encourage all because we really do want to get a lot of local reporting as well on this. That's a big focus of ours. And in the corner here, this is just our first meteorologist here, Jim Gandy. So he has retired many years ago now. And we are in over 200 locations. Currently, we produce graphics and information on most weeks for 247 different media markets. For this analysis in particular, it's just fewer markets, but I'll go over that when we get to it. So what is an urban heat island? I like this EPA definition in particular. There's a lot of definitions out there, and it's when cities replace natural land cover with dense concentrations of pavements, building, and other surfaces that absorb and retain the heat. And they even go into a little bit of the impacts here. It's the energy costs are going to go up, air pollution levels will go up, and heat-related illness and mortality will also be impacted. And I like this because this also speaks directly to how we did our methodology and how we look to measure these heat island effects. So a lot of people ask us, because we are a climate change organization, does climate change impact urban heat islands? And this is a big reason we started to ask this question to begin with, is because people were conflating the two. And a lot of times they were saying, oh, it's only warmer because of urban heat islands. And so we really wanted to kind of divide the issues and make sure we were clear to people the difference. The fact is, climate change is increasing the minimum, the maximum, the average temperature everywhere. City, rural, ocean, everywhere you go, the climate change is increasing the temperature. And so what's happening with an urban heat island is you're generating additional heat that's going to be added to those already increasing temperatures. And so I just did a couple. These are also a demonstration of some of the graphics we do and we send out on a weekly basis. These went out at the beginning of the summer. And these are how some of the temperatures are rising in the Northeast over the summertime. So these are average summertime temperatures. They do not include 2023 yet. And you can see there's a significant rise in most of the cities. Philadelphia is the warmest on this one. And another thing to keep in mind, though this isn't as significant with the urban heat islands, is that the fastest warming season in a lot of these places is winter, actually. So these are probably smaller than the increases would be in the winter time. Another important time to remember is nighttime temperatures. We're hearing more and more about it not cooling off at night. It's staying warm throughout the night. And urban heat island is definitely contributing to that as well. So here are some nighttime temperatures. And if you remember any of the numbers from before, most of them are higher than the daytime temperatures, how they're going up. So we see this consistently across the country, not just in the Northeast. We see minimum temperatures are rising even faster than the average temperature. And so that's going to also be a factor in all this. So just think of these as, before we even start talking about urban heat islands, these are just how the temperatures are changing. Then you put urban heat islands in the equation and we get even a little more heat. The last thing, kind of as an overview here, I want to make sure we talk about is that I feel like I heard better coverage of this summer, but that heat really is the biggest killer with weather. And it's often not taken as seriously as some of the more, I guess, the larger, more sensational natural disasters that go on. But heat is a huge killer. And so we do need to keep in mind and keep people safe with these increased temperatures. And we're seeing a lot of these deaths in urban areas. And so this is just from the National Weather Service, and this is some statistics on the fatalities from heat, from tornadoes, from all the different natural disasters that you think of. And you can see which one is definitely the largest here. And we had some additional fatalities, as I'm sure you all heard of, this summer across the country. And so that's unfortunate. So I focus on urban areas as well. About 90%, 80% of the US population lives in urban areas as defined by the US Census. And I wanted to make that clear because it's not necessarily, the urban area is defined by the US Census doesn't necessarily have to be the big city, but we are talking about developed areas that are distinct from undeveloped farmland or parks and things like that. And what are the major contributors to urban heat islands? I think one thing about urban heat islands is it's very intuitive, I think, to a lot of people about why these things are warmer. And part of our challenge is to quantify this because I think people understand it. Dense layout with tall buildings, traditional building materials. You have these bricks and pavements and things like that, and high population density. I think if you ask people, a lot of people would understand that these are the things that are making it hotter. So our job is to really quantify these factors and make people understand how and how much they're making things worse. So why do Northeast cities have strong urban heat islands? Well, basically because Northeast cities have dense layout with tall buildings, traditional building materials, large populations. So they are very traditional cities in the way that are built that do encourage urban heat islands. You will also hear people talk about how a lot of Northeast cities were built to keep things warm. And now we're under a new paradigm and we don't want to just keep things warm. We also need things to cool off. And so we need to rethink how we design cities. So our methodology, and I should say, going back to kind of what our organization does, we provide data for a broad section of the country, a lot of different areas, a lot of different geographies, different climates. And so our goal is to find approaches that can summarize to the best of our ability to the broadest amount of people. And so for us, the best way to do this was to find a way to model these temperatures. There are a lot of people who've done an amazing job. I will plug right now, heat.gov, going out and measuring temperatures. We unfortunately don't have the ability to go to all these cities and measure the temperatures, but there are great places that are doing that. So our goal was really to find a way that we could look at as many cities as possible that we cover and measure what the impact of the urban heat island is. So we found a methodology, I'll go into it in a second, but basically we divided these urban areas into census tracts. We determined land cover zones, and again, I'll go into define all this in a few minutes in the census tracts. We applied temperature factors, and based on both the land cover zones and on census estimates. Our goal is to also be as local as possible. Unfortunately, defining neighborhoods in cities is not really something which is in our realm. So that's why we use census tracts, hoping when you see our maps that then the local press, the local reporters, whoever was using the data could then translate it into neighborhoods if they needed to, and kind of the people who understand the geography better than we do, because we really couldn't say, you know, this neighborhood starts here and this neighborhood ends here. So the best way for us to do it was to look at census tracts. That was kind of the smallest unit we found that was really workable. So these are the two sources of data and reports I used. The first one down here, the combining expert and crowdsourced, was the base of the map data that we used because we needed these what are called land cover zone maps. So we needed someone who had looked at the whole US and had basically mapped every single square of the US and told us what kind of land cover was there in that city. And so this is a great resource. It's part of a larger effort really to map the globe in this way. And you can find countries all over the world mapped with their land cover zones. And so this was a great one that we used for the US. And we stuck to that. And then the other one where we got our equation for our model was the development of a holistic urban methodology. They were able to apply temperature factors to different parts of the land cover zone. And so with the combination of these two, bringing them together, we were able to measure the kind of land cover zones in different cities and then apply temperature factors and figure out what additional heat would be there because of that. So let's go next. So the equation, I'll start with the equation. The biggest factor in the equation was the albedo, and I'll go into that a little more in a minute. Land cover and population density were really the biggest part of the equation and really made up the biggest contribution of the temperature. This equation was actually developed in Europe, and so the average width of the streets in the US really kind of fell out. It was basically the same. We don't have any of the tiny streets they have there, so this one fell out. The building height was also particularly helpful in the US. So here is the land cover zones, and I'll just kind of do the really high level of this. I just pulled out one, which is fairly common in US cities. And so these are standardized. These are used in many different types of analyses in addition to urban heat island analyses. And like I said, there's maps, there's classifications that you can find that are publicly available that will define these different groups for you. Again, compact mid-rise is a very common one in US cities. Compact high-rise, which you can kind of see up here, is actually, there's not a ton of those in the US. You'll find those in New York and some of the bigger cities. And even that is a smaller proportion of the city. And so there are 17 land cover types. We actually dropped open water from our land cover type. So we were down to 16. And these were found, pretty much all of them were found at least in one of our cities, one of these types, and usually multiples of them. Here is an example of a land cover zone map. It's in LA. Obviously, it's very hard to read at the scale. So I just wanted to kind of give you a sense of how the sort of thing would look on a larger scale. And you can see, kind of going back, this would probably be the high density areas, and then the green representing the brush and shrub. And we know about all these land cover zones. We know different things about how they're made up. So if you go back here, you can kind of see it says dense mix of mid-rise buildings, few or no trees, mostly paved. So what scientists have then done is they've gone and looked at those factors and said, okay, so on average in a compact high-rise zone, the average height of the buildings is 25 meters. In a compact high-rise zone, the average albedo value is 0.15. And so these are the values we used for each of the land cover zones. There's actually a range. We took the average of the range. So just to kind of get somewhat of a basic model value for it. And you can see here, down here, these values, dense trees, no buildings. So there's no heights there because those are areas without built environment. Okay, so I wanted to go back to albedo because it's kind of the star of the show. It really is the largest factor in a lot of these equations. It causes the most amount of heat. And so I think a lot of people on this probably understand albedo even better than I do, but just for the basics, a high albedo is going to be a highly reflective surface, and a low albedo is going to absorb the heat. What we see in a lot of urban areas is low albedo, and it's trapping a lot of that heat. And then in what we're looking for is higher albedo, which is not going to trap that heat, and it will allow the heat to be released from the city. So here are some basic albedo values for some materials you'll find in and outside of cities. This was, I think, from GBH, thank you. Interesting thing, just kind of as an aside to me, is that albedo values change over time. So apparently as concrete gets dirtier, the albedo value then reduces because it becomes darker. Asphalt, as it fades, becomes higher because it becomes more reflective. As you can see, dry soil and wet soil are different. So there's a lot going into these, but this is really the basis of where a lot of the heat comes from in the city. So it's really important to understand the materials. So I'm just going to start with the maps now. So this is a map of Boston, trying to focus here on some of the Northeast cities. So Boston, you can see up here is your downtown area where the heat is most intense. This was an example of a graphic we sent out to our local meteorologists, our local journalists. We emphasized in this one, 9 degrees was kind of where a lot of cities had a significant portion of their population. So we looked at 9 degrees, and that's what we highlighted on these graphics. I'll show you later. There was definitely areas that were much higher than 9 degrees, but this was kind of the sweet spot where a lot of the people were at. So we included the 9 degrees as a number there. If anyone's interested, we have numbers for all the different temperatures. This is just the one we wanted to emphasize. The other thing to note is that when looking for maps, I used some CDC maps of city boundaries. I wanted to capture some area outside the city, but I didn't want to capture the entire MSA. So we arrived at this set of maps. I'm thinking about reconsidering these maps when we go and do further updates. It was interesting because people in Phoenix thought I didn't include enough area, I guess because they're growing fast and they have a lot of sprawl. And then some places on the East Coast thought I included too much area. And so it's a really fine balance to define a metro area and what people want to include within that metro area. More so in the West, it's harder to find than the East. But if you're looking at this and you see it says Boston and you say this is a lot more than Boston, it is. It's a greater Boston area, but not quite the metropolitan statistical area. Here is Philadelphia, where our hosts are from. And again, we can see the downtown concentration here of heat and how it dissipates as you go away from the city. And then 44,000 people at 9 degrees or hotter. And then finally, New York, which is our hotspot, and really by far, not surprisingly, the most amount of people. One of the interesting things I find that's really distinct about the New York map, and I don't even know New York that well, is you can clearly see Central Park here on the middle of the map, the nice long rectangle where it's a little bit cooler. So it's definitely distinct where some of the cooler spots are. The other thing, this is, as I said, we try to overlay it with some transparency so that people in their local areas could see the neighborhoods, could see significant places on the map, would help them to describe to their communities where it was hottest, where it was coolest, and really kind of drill down into these maps, since our expertise is presenting things at the national level and presenting higher level summaries. It was really great actually working with some of the local reporters, walking through these maps with them and having them explain to me where some of the neighborhoods were and what some of the issues in some of those neighborhoods were and some of the characteristics of some of those neighborhoods. So here are some of, like I said, some of the population, percentage of population above degree thresholds. One interesting thing about the Northeast, probably not surprising, we ended up looking at 44 of the largest cities in the country, and we included Newark and New Orleans because on a previous analysis, they were very high on our UHI. They were not two of the biggest cities in the country, but they came back into this analysis. So that's why you see Newark here, because they were kind of winners in a bad way in the last analysis. So we wanted to make sure we drilled down on them as well. But of those 40 some cities, only 12 of them had any percentage of their population above 12 degrees based on the UHI. And you can see, 5 of them were in the Northeast. So a large portion of this urban heat island effect you're seeing in the big Northeast cities. Again, not surprising, New York has the highest percentage kind of across the board, but pretty significant percentages in even the 8-degree level. And we really started at 8 because when you got much below 8, you were looking at almost 100% of the population. And so that was kind of the level where it started to differentiate itself a little bit. And these are based on just census population, the latest census population. We just took the population in the census tract based on where the and what the temperature was in that census tract from our estimate and added those up. So what populations are most affected by urban heat islands? Research has found communities colors and lower income populations, and there's definitely a correlation with historically red line neighborhoods. We did not go into this in this particular iteration. I think we plan on looking at this more next year and trying to drill down into some of these populations. But there is plenty of research already out there that's looked at a lot of cities and a lot of neighborhoods and made this correlation. And it is a very strong correlation that these communities are more challenged with or higher urban heat island effects. So finally, before I initially hand it off to Nikki here, one thing I do like talking about urban heat islands, as opposed to a lot of the things I have to discuss frequently, there are solutions, not solutions to completely eliminate the problem, but there's solutions to help mitigate the problem. And there's solutions that range from very large and expensive solutions to smaller solutions. And so that's one kind of nice thing about discussing this, is you can really get into these solutions with people. A lot of people have probably heard about white roofs, green roofs. Again, the white roofs, you're looking at reflectivity, trying to keep things from absorbing all the heat in the cities. The alternative building materials, you may have heard about cool pavement. In Phoenix a couple of years ago, they painted the roads white. So that's something you can do as well. Adding green space and trees. Green space and trees, not only do they not hold the heat in the same way, but obviously trees are going to provide for you shade, and they're going to provide you heat cooling on the buildings. They're going to provide a refuge. So a lot of people, I talked to someone this summer, and it was very interesting because he was doing basically a thermometer test of urban heat islands, and he was going around his city, and he was going to one space, and he was taking the thermometer, and he would see how hot it was, and then he would kind of go to the tree on the curb and stand under the tree and see how much cooler it was. And he told me he went to one neighborhood and he couldn't find a tree to stand under. So to me, that's the real kind of when you really get to the problem here, is when you're in a neighborhood and you can't even find a tree to go hide under, you don't have any refuge from that urban heat island. And these are the kind of solutions that people can start putting in place. And this is, I think, where Nikki's going to come in and tell us about some community actions, including one that I was lucky enough to see in Philadelphia this summer, which was really amazing. So thank you.
Thank you so much, Jen. That presentation was awesome. Let me go ahead and share my screen. Or actually, I'm thinking, why don't we take a few minutes for questions specifically related to this, and then I'll get into my presentation, just because I see a few populating the Q&A box. So Ruben asks if it would be possible to explore a system that could be used or applied to capture heat being generated in urban heat islands as a potential source of electricity. Yeah, I would love to hear your thoughts.
Yeah, I'm not aware of that, but I do have to say I have attended a couple seminars on urban heat with engineers, architects. It really, I think the problem solving is really running the gamut here. And so I think these are the kind of things that people are trying to think about. They're not just thinking about the simple solutions. They're thinking about, I think someone was talking about changing the way buildings are tilted and things like that. So people really are thinking outside the box. So this could be another avenue. I have no idea, but kind of another area of exploration in the future.
That would be so interesting to see. Thank you, Jen, and thank you, Ruben, for your question. Another question from Richard. He's wondering if you've seen any interesting relationships between urban heat island and dry soil in cities.
We haven't looked at that. We haven't, you know, been able to kind of drill down that specifically, but that's an interesting question. I would like to know more about kind of abandoned areas and things like that, you know, kind of where that reads on the spectrum, because I know we have a lot of cities with areas that maybe were formerly buildings and are now basically dry lots and things like that. So I think it's an interesting question and definitely worth something looking into.
Awesome. Thank you. And then last question we have is from an anonymous attendee. They're wondering, do you think we need to plant more urban street trees in order to help reflect heat in major US cities to help with urban heat island effect?
I think it's definitely one of the solutions. And I think one of the appeals of it is a more affordable solution. I'm not going to necessarily say it's a cheap solution or an easy solution, but it's a more affordable solution. And it's a solution where I think a community can come together and make some decisions and say, you know, this is what we want to do. I often think about things, again, I've talked to a lot of people about this now, even thinking about things like by a bus stop or something like that, where people are standing outside for a long period of time. You know, can you put a tree by that so people can maybe stand under a tree while they wait for the bus? So I think that is definitely one of the first line solutions that comes to mind when communities start thinking about how to mitigate urban heat islands, are trees. So everyone loves to plant a tree.
Absolutely. Thank you. And then I'll take one more question before diving into my presentation. Someone's asking if you can list maybe some examples of thinking outside of the box for reducing urban heat island impacts.
I think, like I said, different alternate building materials is one that I'm finding really interesting. You know, if you kind of Google pavement and concrete and things like that, you know, you find an amazing amount of people are just trying to color things differently, which is interesting to me. And like I said, building shape, building size, building orientation, people are thinking about, you know, making kind of the urban canals different. One thing I just realized I should have mentioned and should have stressed more, and I don't know how I missed it, was population density. I don't know how I completely missed this one, but population density is huge, and it's becoming more of a problem because it is getting hotter. And so we're using more air conditioners, we're generating more electricity, and a lot of that waste heat is being shoved out into the streets, into the city. And so when you think of innovative solutions, you also think of a lot of these innovative solutions we have around cooling. And how are we going to cool our world, and how are we going to cool our world more efficiently and without generating all this waste heat and using all the electricity? So I think that's another place. So I'm glad you asked that, because that reminded me of something I forgot, and some place that there may be some really innovative solutions coming.
Yeah, absolutely. Thank you, Jen, for that awesome response. And thank you for your question, Anonymous. So I think that's good timing for me to jump into my presentation, which talks about one of the solutions that we engaged in this summer in Philly. Okay. Alrighty. So yeah, thank you again, Jen, for your presentation. You gave some awesome information. Hi, everyone. As Franco mentioned earlier, my name is Nikki, and I manage the Sustainable Water Resource Engineering Lab at Drexel. I also help coordinate these monthly seminars with CC Run. So I'm going to talk to you about a heat mitigation initiative that we spearheaded in Philadelphia neighborhoods this summer to help mitigate excessive heat that we're experiencing in Philly because of urban heat island effect that Jen just presented on. So I'll start with some quick background on this project, but I will be kind of brief since we actually did another seminar on this project with a bit more of a deep dive last summer that you can review on the CC Run website. But for some basic background, back in 2020, when everything was shut down due to the COVID-19 pandemic, NOAA, which is the National Oceanic Atmospheric Administration, issued a 3-month outlook figure, which you can see on the left, which basically said that we were entering a summer with projected above average extreme heat. And since cooling centers and pools and libraries, etc., were all closed due to the pandemic, and coupled with the fact that a lot of people were out of work, there weren't a whole lot of options for escaping the heat. So Dr. Franco Montalto of Drexel approached the William Penn Foundation and proposed a project that would address extreme heat while also offering socially distanced employment opportunities for community members. So Drexel researchers worked to develop a pilot project that would overlap with real community needs, heat vulnerability factors, social distancing guidelines, and the ability to cope with urban heat in place outdoors. So the team looked at several case studies to see how people historically have done things to address this issue in the past. So, for example, you'll see later in my slides that we actually gave folks the option to receive a sprinkler because we learned that in Japan, evidently for hundreds of years, folks have sprayed water onto pavement in the summer. That caused the water to evaporate and thus cool the pavement down in the process. So through those case studies, we came up with a bunch of different ideas and eventually produced a pilot project for one block in the Hunting Park neighborhood of North Philadelphia. And we picked Hunting Park because at the time, I'm sure many of you remember, the Office of Sustainability had just released a Beat the Heat study that really underscored the needs of the Hunting Park community as a heat vulnerable neighborhood. So we reached out to Esperanza, which is an amazing local nonprofit based in Hunting Park, and started this collaboration that has grown into what we know it as today. So instead of showing up to this block in Hunting Park and saying, here, this is what we have, take this, we really wanted to work with the community as an equal partner to figure out ways that we could address multiple sets of community needs while also addressing extreme heat. So the photo on the left shows that initial meeting that we had with the block captain and some of the other residents. And there was a need expressed for gathering spaces for community building, for beautification, and for people to explore different outlets like gardening. And then, of course, the need to have some relief from the heat. And the drawing on the right shows an initial concept that we came up with based on those early conversations. So with refinements done through interactions with the street department and with our architectural partners, we developed this final design for a shade structure with an umbrella that also functioned as a bench for people to sit at, and then the backrest served as a planter. And it was designed to be so that it was kind of a removable structure, meaning it wasn't causing any permanent damage to the property, but it was also heavy enough that it's stable, it couldn't be stolen, and the umbrella was designed with a pin lock to hold it in place even under severe windy conditions. Here's some additional photos that you can see from our pilot block. You can see one of our Esperanza partners standing under the umbrella and the shade that it provides to what otherwise would have been a shadeless front step. Here's some more photos. You can see the different benches lining the street. And then here, as I kind of mentioned earlier, we did provide sprinklers to residents so that they could use them for kids to play in during the summer, as well as to help cool the pavement down on blocks. So this map shows the total planter bench installs or shade station installs, I kind of use those terms interchangeably, that we did in Hunting Park to date. So we started with the one pilot block in 2020, and then through the summer of 2022, we expanded onto 9 additional blocks and ultimately ended up installing just over 200 planter benches for residents in Hunting Park. So getting into the work that we did this year, we received additional funding from the William Penn Foundation to expand our project into more heat vulnerable communities throughout the city. And we worked with another William Penn funded project with the team of the Academy National Sciences called the Resilient Community Stormwater Initiative to identify neighborhoods that would benefit from shade stations or additional green spaces. And we ended up identifying 3 neighborhoods and 4 community partners to work with in this expansion, being Point Breeze Community Network Plus and residents organized for advocacy and direction in the Point Breeze Grace Ferry area, and then Empowered CDC in King Sessing and Global Thinking Initiatives Incorporated in Haddington. So for this expansion, for each community, we committed to providing 60 planter benches, but we were ultimately able to provide closer to 70 or just over 200 additional benches installed throughout the Philadelphia area this summer. And then here I've included some maps depicting where the planter benches were installed. So this map specifically highlights installations in the Point Breeze Grace Ferry area. I have those blocks highlighted in different shades of green for you to see. This map indicates installations in King Sessing. And this map lastly indicates planter benches that were installed in the Haddington neighborhood. So in addition to installing planter benches or shade stations, again, I kind of use the term interchangeably, we also wanted to do some monitoring work and data collection to measure the differences in surface temperature and wet bulb globe temperature on blocks that have planter bench installations versus blocks that have heavy tree canopy versus blocks that have no shade at all, to kind of see the differences. And we used wet bulb globe temperature as our primary metric because it accounts for things like humidity, wind speed, sun angle, cloud cover, UV radiation, a whole bunch of different things in order to most accurately depict heat stress and its impact on the human body. So in each neighborhood, we installed a fixed QT44 wet bulb globe temperature sensor, which you see on the rightest part of the screen. And then we also hired civic scientists from each community to do a walking route in each neighborhood and collect the same data at various points on different blocks throughout the neighborhood over the course of the summer. And this data is currently being analyzed by an amazing master student in our lab, who I think is one of our participants today. So hi, Samantha. And we hope to have the first round of analysis done later this fall or sometime this winter. So now let's talk about impact. We observed several positive impacts resulting from these shade station installs. For example, we've seen the benches really promote social interaction on blocks now that folks have a comfortable place to sit and chat with their neighbors. We've also had reports of them actually promoting exercise. One resident in Hunting Park in particular comes to mind. He's this lovely senior citizen who now enjoys walking to his local food store, which is something he could never do before because his block is on a pretty significant slope. But now that we have shade stations lining his block, he has the ability to walk up and down the block and has a place to stop and, you know, catch his breath and take breaks in order for him to walk to the food store, which was something he hadn't been able to do previously. Other impacts include beautification of the block. At least in my opinion, I think the benches look really nice and they add greenery and color to the blocks. And consequently, we've had a lot of reports of residents taking extra care of their block because, you know, they're proud of these things and they want to show off their block and how great they look. And on a similar note, folks are having fun with these benches. You know, they're decorating them, they're painting them, they're adding seasonal decorations, particularly for Halloween, which has been super fun to see. And they're just really making them their own, which is awesome in my opinion. So as I kind of alluded to at the beginning of my presentation, a big part of this project, in addition to providing an escape from the heat, is workforce development. So we were able to provide community members with temporary employment and job training throughout the course of this project. So what you see in these photos are images of folks that we hired from the community to work with us, and they were trained to build and install the shade stations in each of their respective neighborhoods under the supervision of our project architect. And here we have some photos of civic scientists that were hired and trained to help us with that monitoring and data collection in each community. These civic scientists were hired to follow a walking route, as I mentioned, in each of their respective communities to collect surface temperature data and wet bulb globe temperature data at various points along the walking route, Monday through Friday, every single day throughout the summer. And that's the data that's currently being analyzed. And we'll also compare it to the fixed QT44 wet bulb globe temperature data that we collected as well. So looking ahead, we plan on installing more benches in these neighborhoods next summer. As I mentioned, we installed just over 200 benches this summer alone, and that sparked a waiting list of an additional 200 plus people that are interested and eligible to receive these benches, both in the current communities that we're working with and in additional communities that we haven't worked in before. So we're currently exploring opportunities for funding so that we can expand this project into even more neighborhoods for the summer of 2024. And before I wrap up, I just really want to take a moment and make sure I thank all of our partners on this project, because they truly, we could not do this without them. I particularly want to highlight how critical the community partners' role in this project is and continues to be, with their community expertise, with their ability to help us identify blocks that could really benefit from these shade stations, and receiving sprinklers. And they also helped us identify and recruit those construction ambassadors and civic scientists that we trained. Like, again, none of this could be done without them. So I want to give particular shout outs to Empowered CDC, Global Thinking Initiatives Incorporated, Point Breeze Community Network Plus, Residents Organized for Advocacy and Direction, and Esperanza. And I'd also like to thank Arxis League, who is our architectural partner on this project, as well as the Land Health Institute, who provided native pollinator-friendly plants to everyone who received benches this summer and in previous summers. And lastly, I want to thank my colleagues at in the Resilient Community Stormwater Initiative Project, and as well as William Penn for funding this amazing work. Thank you all for listening. So now we'll move into another Q&A session. So if you guys have any questions for me or for Jen, you can put them in the Q&A box and we'll get them answered. All righty, let's see. So we have one question from Peter, who asks how these benches and umbrellas have held up 1 year later. So we've had benches installed throughout the city since 2020. And before we started our installs for this summer in particular, we went to all of the blocks up in Hunting Park to kind of see how the plants were doing and how the benches were doing. And they're doing awesome. You know, the plants we provided are really thriving, and some people have added their own additional plants, and some people paint them, and they seem to be holding up really well. So thank you for that question. Let's see. Dan asked who maintains these benches and how is that built into budgets and funding, etc. So one thing that we express to the residents before they before they receive the planter bench is that once they are installed, it is their responsibility. So we do give them some information on how to care for the plants, as well as some tips and tricks for maintaining the benches. But ultimately after that, it is their responsibility to tend to the bench and the plants. Richard asked if there's any initial takeaways, interesting initial takeaways coming out of the heat data. We actually just started analyzing the data this week. So at this point, I don't have any information to report, but like I said, we should have some initial analysis done later this fall, and even more coming this winter. So thank you for that. Let's see, Josh asked, in one photo, I noticed a window AC unit directly on a shelter bench. Have you formulated a list of criteria of placement, like surface and surrounding material? That's a good question. We do have some criteria. For example, we try to steer away from blocks that have, you know, a lot of street trees, because the point is to provide an alternative for shade and relief from the heat to those blocks that wouldn't otherwise have any other option. And we also, sometimes we can give benches to folks with porches, sometimes we don't. It just kind of depends on what the need is in that particular neighborhood. As far as AC specifically, we don't have that as a eligibility criteria, but that would be interesting to look into in the future. Lawrence asked if the planter box, the shade stations promote social interaction and reduce crime. So we have had reports of that from residents, particularly because we're installing these on blocks that don't have other benches or porches or any sort of outdoor space to encourage social interaction. Once we put those benches on those blocks and they have that, we have heard that people are spending more time on their bench in the front talking to their neighbors. And because there's more of that community presence, one of the benefits is that it has at least been reported to us, seems to reduce crime. So thank you for that question. Are the benches to individual homeowners or community groups? So overwhelmingly, we give it to the residents. if they're homeowners, then they get the bench. If they're renters, then we just ask that they get like a verbal yes from their landlord, just to make sure we're not ruffling any feathers. There were some instances where in the communities we worked in, there were like community garden spaces. So when the resources were available, we did provide a few benches to those kinds of groups as well. Getting a lot of questions in. Thanks, guys. Keep it coming. What kind of continued community impacts do you anticipate in terms of residents leading other kind of projects or growing their professional skills? Good question. Thank you for asking. So again, when it comes to community impacts, it encourages a lot more socialization with neighbors because it provides folks a comfortable place to sit. And then also, again, the benches look really nice. So when we add this beautification to the block, folks tend to be more motivated to help keep their block clean. We find a lot of these blocks that are receiving benches also have residents, going out and cleaning up trash a bit more, which is great. And as far as professional skills goes, the folks that we hire to help construct the planter benches receive really valuable carpentry skills that they can take into the job market after this project ends. Let's see. How much is the unit cost of each bench install? And do you think that would be helpful information to have when trying to scale up? Thank you, Amelia, for your question. I think there is a unit cost for each bench install. I personally don't know it off the top of my head, but in your question, I'm going to type out my email. So if you want to reach out to me, and this goes for anyone, I can contact our project architect who would have that information, and I can send that to anyone who's interested. Are any umbrellas made with reflective material, and is this possible to include? Lisa, that's a very good question. No, but that would be something really interesting to look into. And I had another person earlier in the summer email me with a similar question, asking if we could paint the benches with a reflective or heat resistant paint, which again is something that we haven't looked into, but that would be really interesting to explore in future developments of this project. Let's see, what else? How well have these benches held up 1 year later? I think I might have answered this, but they're holding up well. We've had some instances where like if folks leave their umbrellas out long term, the color kind of fades from sun bleaching. But other than that, we haven't really had any reports of significant damage or issues with the plants or the umbrellas or the benches themselves. Did I say that we will be providing a future presentation as part of these seminars once the data is analyzed, so the wet bulb globe temperature data has been analyzed? I did not say that, but that is likely going to happen. Probably maybe this upcoming spring, we would have some data to share, which would be a really interesting seminar. Diane also asked if the plants are perennial or will they need to be replanted. I believe they're perennial, so they would not need to be replanted every summer. But I think, as I touched on, some people also add their own annual plants to their planter box, just to kind of enhance it and make it their own. So kind of a yes and no to that question. Keep them coming, folks. These are great.
And I can jump in on Lisa's question here from
Okay, great.
a
Thank
while
you.
ago. Yeah, I don't want to cut in there about population density, and I think that's a good question. We do think population density is a good thing, but it also does generate heat. I think you've kind of have it right here, is that we're not. I don't think the world is moving towards less density, because there are benefits as far as walking and transportation and things like that, and just more efficient living. But as you mentioned, permeable surfaces, making sure there are green spaces interspersed between these, making sure the buildings are built maybe with green roofs, with white roofs, things like that. So I think it's really rethinking our cities. That this seems kind of cliche, I know, but that's really the way forward, because the world is going to become more dense. It's not really a question. And so it's how do we handle it? And like I said, I think the elephant in the room always with climate change is air conditioning, because we don't want people to not use air conditioning and get sick and do harm to themselves, but at the same time it can be very detrimental. So there's a lot of work that needs to be done with that so people can stay cool, and we don't further harm the environment. So fortunately, again, people are thinking of creative solutions for that. So yeah, I think this is where ingenuity is going to have to come in, because we're not moving away from density, and I don't think we want to encourage that necessarily.
Thank you, Jen. Let's see. The city of Philadelphia should explore and consider giving credits as part of permitting, as part of the permitting process for new or replacement sidewalks, parking lots, etc., using pervious pavement in lieu of concrete or asphalt surfaces. That's an interesting idea, Ruben. Thank you.
And I was going to address Josh's question broadly. We don't do policy work here. We don't, necessarily look at those. But I think part of this kind of goes back to my example with, the reporter who couldn't find a tree, that it's not always necessarily, what Nikki's working on is putting something really in front of a house, at a house, but they're also community-wide solutions. So I think at some level, you also just want people to have some access. It may not be immediately in their, in their yard, but to have some access to cooling and shelter and some mitigation of this. And that may be the first step. And some of these communities, I think that's the thing, they don't even have quick access to a park. I mean, it's not even a question of is their house cool? It's a question of, 5-6 blocks. And as Nikki was talking about, I know I spent a day with them in Philadelphia, and a lot of the residents, they told me everyone on their block was over 65. And they said, we can't walk very far, we can't go very far. And so even if a park is, 3 or 4 blocks away. So I think sometimes it doesn't necessarily need to be hyper localized, but at least accessible to the residents to allow them the ability to cool off.
Absolutely, Jen. And that reminds me of something that was brought up a lot this summer, but also in previous summers doing this heat mitigation work. And that's with accessibility and street trees. Like you said, a lot of people love street trees. They're great. I mean, who hates a tree? Like, come on. But young street trees require a lot of maintenance and a lot of resources to take care of and maintain. And that's not always accessible to people. So while street trees are great, we want to be able to provide some other options for shade and green spaces as well, which is another part of the inspiration of this shade structure planter bench project. Carl asks, any thoughts about managing microclimates in urban areas to help mitigate urban heat island impact?
I don't have any particular solutions to that. I think urban areas are full of microclimates, unfortunately. And that's really, I think, where the community needs to educate itself as much as possible and do kind of these street by street analyses to figure out how different environments are. So unfortunately, I don't have any good answers for that one. So, and I see about the bus shelters, it's interesting. I spoke to someone and they were looking at just traditional bus shelters, and apparently they were getting very hot. And so some people are also thinking about a bus shelter and how much coolness that represents, because they were measuring, again, people are running all over cities with thermometers. They were measuring the temperature in bus shelters, and they were finding it was actually hotter in the bus shelter, I guess, because the wind was blocked and it was all metal. And so that's another thing. And I can't remember, that was somewhere in Texas. And so I think they were thinking about alternate design for bus shelters, or if it would be better just to have something like trees there to cool people. So
definitely a lot of creative avenues to explore, for sure. Carl asked, any thoughts on qualitative albedo values to help set goals for heat island mitigation?
Not sure I completely follow the question, but I think it's obviously it's a big part of the equation, if that's what you're saying, and it has to be a consideration, I think, when any sort of new design or new development goes into place, is that reflectivity and how much. This is also an issue with, I kind of talked a little bit about nighttime temperatures. A lot of that heat is re-released in the night, that heat that's absorbed in pavement and buildings. And so that will also help elevate the temperature at night. And so that's another reason these albedo values are kind of an important thing to consider in cities, to keep the nighttime temperatures down as well. It's kind of, when the sun goes down, you don't expect the heat to go up.
Thank you. That's all the questions in the Q&A box. So if you have any other questions or thoughts, keep them coming. In the meantime, I have a question for you, Jen. I noticed when you were talking about the nighttime temperatures, I think the other cities, it was Baltimore and a few others, they were kind of like 2 point something, but I was shocked to see that Philly was 4 point something. And I didn't know if you had any insight as to why there would be such a difference in Philly in particular. But I'd love to hear it if so.
No, unfortunately, we see patterns regionally, but kind of specific values can, it's all up. We use temperature station data. So sometimes it's depending on the temperature station, kind of going back to Carl's talking about microclimates. Right. There can be particular microclimates around the temperature. So what we see more than anything is, you saw all those were in the, 2.5 to 3.5. And then in other parts of the country, you'll see they're in the 1 to 1.5. So you'll see more kind of clustering like that. But as far as kind of the specific values being higher or lower, there's a lot of factors that may go into that. So, yeah. So don't worry that Philadelphia is necessarily going to be the hottest place on the East Coast.
It just stuck out to me. I am in Philly, so I had to ask. So thank you for that. Any other questions that folks have? Questions, comments, concerns, compliments, anything, we'll take it. Richard, Jen, for you, Jen, have you seen any interesting relationships between heat and proximity to water? So in our case, rivers in particular.
Yeah, and actually that's something we're hoping to kind of investigate more in the modeling next year, because again, it all goes back to the albedo values. With the water, are kind of reading it higher in some cases, and so we are going to investigate kind of the relationship of water bodies to some of the areas, especially because a lot of major cities are on large water bodies. So it's and some of them, we find like Miami, where there's a lot of water kind of coming through the city and weaving through the city, it's having a particular impact on the temperature. So that's something actually very specifically I'd like to investigate. I've already talked to my team about for next year, is to figure out how to maybe factor out those water bodies or kind of account for them and the heat they generate. The other thing, and I don't know if we can do this as well, a lot of questions about the wind and the coolness off the water. I don't know how exactly, I think that's a little more difficult. I had a lot of people from, say, San Francisco, for example, ask me how I account for the cool breeze off the bay, and that's not really in there. So I think that one is probably not going to be incorporated, kind of that factor of water bodies, but there is something about the water body as a land cover type that I would like to dig into a little more and understand a little more, because we did notice, and you'll see on the maps, that some of those areas are reading hotter, and I'd like to understand that a little better.
Great, thank you. Any other questions? I'm in the process of reading Lisa's.
Yeah. I was looking at Carl's here real quickly while you're digesting Lisa's journey. The West Coast is also a very interesting case, though. A lot of times the old kind of way, the traditional way to measure a heat island was you would take a thermometer in a city location, and then you would take a thermometer in a quote unquote rural location and take the difference between the two temperatures. Maybe a few in the city, a few rural. Again, you're kind of dealing with single points. And so you're limiting yourself in that way, and what is the rural location? And interestingly, in the West, a lot of times you would find it was not that much different because it's hot in the desert. So the desert seems to present its own special climate, and I'm not sure about that, but I think it is going to take different solutions in the West to deal with urban heat islands than it necessarily is in the East. They also just don't have the availability to plant the same kind of trees and things like we do. And there is a component of moisture that does have some cooling, which seems strange to us in the East Coast when summer moisture seems like just bad. So yeah, I think the West is probably going to have a different set. Some of the solutions are going to be different than it would be on the East Coast or in the urban, like California area.
Absolutely. And Lisa's point talks about how it would be interesting to kind of record temperatures in different areas. So for example, going to what one could consider a more wealthy part of town, the place that has a lot of green space, a lot of trees, more space in between buildings, and then comparing that to an area that might be deemed as less wealthy, where there's less street trees, more attached buildings, and kind of seeing the difference in temperatures. And there definitely is a difference. Blocks that don't have trees are typically hotter than those that do have trees, and uncoincidentally, the blocks that don't have a lot of trees are typically those that have been redlined, and they're typically BIPOC, lower income communities. So that's where, like environmental racism comes in. And that's definitely something that is being explored more through the environmental justice movement. But it definitely, needs to be investigated further for sure. And I know one thing that came to light through this project is the concern of adding green space to low income communities and them therefore being gentrified and priced out because of those green spaces that are added. And that's a task that myself and my colleagues and everyone doing this work are trying to tackle every single day. So thank you for bringing up that point.
I actually was looking through the comments, and I wanted to go back to one of the first ones. Someone who works on the iTrees project had noted there, and I just wanted to kind of give another plug for that tool, which is really has many dimensions and is really very useful. We use the iTrees a lot here to kind of find out where the green space is in the country. And so, yeah, just another plug, because I know that one came in very early in the seminar today for the iTrees tool, and all the tools. There's a lot of tools in that.
Sandy just asked if there's a plan to meet with developers to stop replacing single dwelling homes with apartment buildings and to, constantly building on green spaces. I don't have the answer to that question, but it's definitely something that, needs to be addressed. Absolutely.
And I cannot speak to geothermal, but again, it's just interesting. Even with the seminar, you see how many different creative ideas people have. And so it's, yeah, we'll see where it goes. Yeah,
absolutely. I mean, I consider this like a collaborative space. It's really interesting to hear, different people's ideas, kind of going back to how, the East Coast solutions don't necessarily fit West Coast solutions. It's all very personal. So the more we talk with our communities and other experts, the better. Carl, thank you for sending these awesome resources. I'm definitely going to be looking into these later. Any other questions? Also, I'm going to put my email in the chat. So if you have any questions that come up after the seminar, you're more than welcome to reach out to me. And Jen, if you want to do the same, you're welcome to. Definitely reach out if something comes up. Richard says, thank you. This has been insightful. Looking forward to future conversations. Keep up the great work. Thank you, Richard. Feelings mutual. Thanks for coming. Always great to work with you.
All right.
Sam says wonderful presentations. Thank you, Sam, for analyzing our data. I look forward to future conversations with you about that this fall and winter. And hopefully you and I can do a seminar like this in the future where we talk about the data that we collected. Lisa's interested, Jen, in your comments on the West and the desert.
I think that's really what it is that it is, you see all these analyses that, say you're in Philadelphia and you drive outside the city, you drive into the forest and you drive into the trees and it's cooler. And then in the West, you drive into the West. So I think it was more when the old way that you would measure the urban heat islands, you didn't get the significant difference because the surrounding area was sometimes just as warm as the city. Hopefully now with these models that are including development, including more of the structure and things like that, you're going to be able to account for the fact that even though it is very hot in the desert, and you're not going to get much, respite from the heat, and you are still have factors in the city area that are keeping you warmer. I guess one last thing too is to this kind of sprawl thing. We're also hoping with including some of the outer cities in the map, we could show that because this is about development and about materials and about buildup, that you can make other areas warm too by overly building them up and so in not accounting for these things. So you're not necessarily immune from elevated heat if you have an area outside the city which doesn't have any sort of green space or cooling anyway. And so that's another, I think, advantage of looking to kind of a greater area. So yeah, the West is an interesting place and being so different. I admit to being a Midwesterner and an East Coaster, so it's still somewhat foreign to me.
Me too, Jen. Born and raised in St. Louis. Awesome. Thanks, everyone. Any other last minute questions? Thank you, Ruben. In the meantime, all of these sessions are recorded and uploaded to our CC Run website. So if you miss something or you want to watch it again or share it with your friends, this will be uploaded to the CC Run website probably within the next 2 weeks or so. We usually have a faster turnaround, but our website is actually under construction. So it might take a little bit more time for it to be uploaded to our website. However, if you would like to see the recording sooner, I'm happy to send you a Google Cloud link if you just reach out to me via email.
Thank you so much for the invite, Nikki. It's really
Thank you so much, Jen, for presenting on Urban Heat Island Effect. It was great to meet you when we got some news coverage on this project. So thanks. Carl's asking if climate change impacted the wildfires in Hawaii.
Whole different discussion.
Whole different discussion. I will say that climate change definitely makes weather events and weather-related events more frequent and less predictable. So, yeah. Anything else? I'll give you all another minute or so, and then we'll come to an end of our October seminar. Our next seminar, so like I said, we do these first Wednesday of every single month from 4 to 6. So our next one will be November 1st. I'll send an email about that with topic information 2 weeks before the date. So be on the lookout for that. Right. I'm not seeing any more questions come in, but if something pops into your brain later on, you have both of our emails. Never hesitate to reach out. Jen and I are happy to answer any questions that you all have. Thank you all so much for coming to this monthly seminar. And I know it's been a while because we took a break over the summer. So thank you. I hope you all had a nice summer. I hope you're entering your fall well. And yeah, again, thank you all for coming. And reach out if you have any questions. Otherwise, I hope you have a good rest of your evening. And thank you, Jen. I'll be in touch and I'll send you the recording for everything and stuff tomorrow or so. Bye, everyone.